Hey everybody, I had a request to determine how many watts this amp is putting out. Now we know it's rated for 15, but we have to be able to rate it from an RMS perspective, which is typically the way we want to do this. So I'm going to go through that exercise for you. So I've reconfigured the output transformer for 8 ohms so I can test it properly. I have an 8 ohm dummy load here, and I have my meter connected to it as well as my oscilloscope, which is right there. My audio generator, right there, is set for 1,000 cycles right there. So we're gonna get this all hooked up, and I'll show you what the RMS output is on it. Be right back. Okay, so in order to do this, we're going to use Ohm's law, right? So let's do our measurements first, and then we'll do the math, and we'll show you the calculation. So again, I have our signal generator going right there. I have our amp on, and here's our meter. I'll show you a picture of the meter. There it is. And I'll put the meter up in the corner here so you can see it. All right, so let's turn the amp up. And what we want to do is we want to turn the volume up until that signal starts to break. Right there. See it? And then what we want to do is we want to back down. Right about there. And if you look at our meter, we're getting 9.22 volts AC. Okay? So just remember that number. Okay, let's go do the math on a piece of paper and we'll show you what it looks like. Be right back. Okay, so in order to figure out the RMS output of this amplifier, we're going to use Ohm's law. Power equals voltage squared over resistance. Okay? So, let's start. Power equals, and if you remember, the voltage that we measured on our meter was 9.22. And we're going to square it. All right? And that's going to be over the resistance. So 9.22 times 9.22 is going to be 85.0 over 8 ohm speaker. Okay? So we're going to divide. 85.00 divided by 8 is going to give us an effective RMS of 10.62 watts, RMS. Very respectable for this amp. Okay? Now keep in mind, it is a 15 watt amp, but this is right before the signal starts to break up, right? We never want to just continuously overdrive an amp. So what this tells you is that we're getting 10 watts out of the amp before it starts to break up. Now we could adjust the cathode bias resistor and maybe tweak this up a little bit. We could absolutely do that. I'm not going to do it in this amp because I'm satisfied with it the way it is. But we could throw a decade box on there. I have a power resistor decade box, and we could play with that number a little bit and maybe drive a little more power out of it. But I think this is going to be comfortable for those tubes. So I hope this makes sense. I wanted to just explain what the setting looks like. Now keep in mind, there's other ways to do this. So you could use the meter method that I showed you. You could also use the scope. But if you use the scope, it's a little bit more complicated because you got to remember you're measuring AC here. So this calculation works well. Like if you were using a DC circuit where the voltage is constant, it would be much easier. But in AC, obviously, you know you've got this going on. So you have to do a little bit of a different kind of calculation in order to get to convert peak to RMS. Right? So peak is what if you looked at the oscilloscope that I showed you, you'd be able to determine what's the peak. So we're going to use the meter method here just to be quick and dirty. It would come out about the same thing anyway. So the only thing lastly I'll mention on this is this number is going to change. So if I use a different frequency, instead of 1,000 cycles, if I change it to 800 cycles, or if I changed it to 60 cycles, that number is going to change. So it is based on the frequency going into the amp. I hope this helps. That's what we're pumping out. Take care, folks.